Hello, everyone. Welcome back to a GRE prep hour. I am your host, Tyler, and I am an instructor and a tutor with Manhattan Prep. And I like doing these prep hours because it's an opportunity for me to kind of go deeper into a topic that we often don't have the time to cover in our regular classes. And today, what I've got planned is we're talking about sequences, which are a pretty difficult topic. Not the most popular thing, but when they show up, they can be pretty tricky. So I'm going to be giving you some tips on how to best handle these. If you've never been to a prep hour before, the way this works is I am teaching this session live in a Zoom room right now, but it's also going to get recorded and put up on YouTube later. So big welcome, regardless of whether you're here in the room with me live or whether you're watching on the internet later. If you are in the room with me live right now, in the chat box, why don't you go ahead and tell me what city you are connecting from or what country in the world you're connecting from. Myself, I am in San Francisco, California. It's a lovely January day where, winter's here. It only gets down to like mid 40s. It's not too bad. I hope you are not snowed in somewhere else. Hope the weather's nice where you are. All right, we got the UAE represented. Bit of an international crew. We got New Jersey on the East Coast, Manhattan on the East Coast. Very cool. All right, well, thanks for saying hi out there. All right, and Chris in LA. Hey, hope you're all doing okay with those fires down there. I know a couple people that had to evacuate, so scary stuff. Hope you're taking care of yourself down there. As mentioned, we're going to talk more about sequences here. And before I show you some problems, I want to tell you all a quick thing just about sequence notation, because it's often written with this big S, and then you have like a subscript. So you would say this as S sub n. If you see that, S sub n is really just a shorthand way of writing the current term. And then you might see something like S sub n plus 1. That's going to represent the next term. And then you also might see S sub n minus 1, which is a stand-in for the previous term. So now that you know those basics, I'm just going to toss you into the deep end with a real practice problem. Try it out. Once you have an answer, if you're here in the room, chat it to me, and I'll tell you whether you're right or wrong and give you some hints. I'll give you 2 or 3 minutes on this one. All right, so one tip I have for these sequences is when you have a mathematical definition like this, I think it's a little easier to try and transcribe the math into plain words. So what I see here is the current term, right, S sub n, that is going to be equal to 2 times the previous term, that S sub n minus 1, plus 3. And once I have it written in words, it's going to be easier for me to just kind of move through the different members of the sequence rather than try and like recalculate an equation every single time. So I'm told the third term is 6. So to find the fourth term, I double it and then I add 3 to get 15. And to get the fifth term, I double 15 and add 3. The fifth term is what I'm solving for, so that's 33. If I wanted to keep going, if they had asked me for the sixth term, I would just do the same thing, double it and add 3. Your sixth term is 69. But for extra credit, this is a little more difficult. What if I were moving backwards? What if I went back from the third term to the second term? What is the second value of this sequence? So if you're moving backwards, you want to do the opposite operation in the reverse order. So first thing you would do is not add, but subtract 3, and then divide rather than multiply by 2. So subtract 3, you're at 3, divide by 2. The answer is 3 halves, or 1.5 if you prefer a decimal. Big things, though, are 1, try to define sequences with words. That can often make it faster and easier to process multiple terms. And then 2, if you're moving backwards, you want to do the opposite operation in the reverse order. So let's get a little more practice with that skill. Here is another sequence. Try this one out and chat your answer to me when you're done. The first thing I would do in this problem is take the sequence definition and rewrite it in words. So I have the current term is 3 times the previous term minus 5. And we are starting with the fifth term we know is negative 38, and we're trying to move back to the second term. If I was moving forward to the sixth term, I would multiply by 3 and then subtract 5. But if I want to move backwards in the sequence, I need to do the reverse order and the opposite operation. So I want to first add 5 and then divide by 3. So I add 5, I'm at negative 33. Divide by 3, and then you'll be at negative 11. And that's the fourth term. And then I move backwards another step. I add 5, and I'm at negative 6. Divide by 3, and I'm at negative 2. And then I just need to do that one more time. You add 5, and you'll be at positive 3. Divide positive 3 by 3, and you end with positive 1, which is answer choice B. All right, so here is one more. I won't say anything else. I'll just give it to you. Try this one. In this problem, they've actually already given you a definition in words, but there's a lot of steps here that we're trying to figure out the seventh term if we only know the first two. And really, it's just going to be taking lots of averages. So I think the key here, it's not that the math is crazy difficult. It's just a matter of staying organized. And make sure you don't do too much in your head. All right, the more you try and do your head, the easier it is to just make a simple mistake. So I would just be really meticulous with my scratch work to make sure I don't mess anything up. So your first two terms are 2 and 10. You take the average of those, and you'll get 6. So then you need to average 10 and 6, which is going to be 8. And then you take the average of 6 and 8, and you get 7. The average of 7 and 8 is 7.5 or 15 halves. And then, by the way, at this point, I would prefer using fractions. Some people ask me, should I put it in decimal form or fraction form? I would prefer using a fraction here. And the reason why is because I already looked at the answers at the start of the problem to see what formats were available. And the fact that fractions show up here, that tells me I want my scratch work to model the available answers, so I should be using fractions as well. So now I've got my fifth and sixth terms, so I have to take the average between 7 and 15 halves. So combine them, divide by 2, you will get 29 fourths, which is choice E. All right, this next one is a little trickier. Try it out. So in words, you might say that the current term is equal to the next term plus the previous term divided by 2. Or if you want to think more conceptually, you can recognize it's the average of your next term and your previous term. And I know that the first term is 15. So the second term is going to be the average of the third term and the first term. I don't yet know the third term, so I'm just going to leave that written as S3. And S3 itself is the average of the fourth term and the second term. And I know the fourth term, so that's where that 10.5 comes from. From here, what I'm going to do is take that S sub 3 in my definition of the second term and replace it with this entire definition right here. And I will get something that looks like this. So kind of this ugly nested fraction, but that's okay. I'm moving towards the right answer of solving for S sub 2. And what I want to do next is just multiply both halves of this equation by 2. So now I've got something a little friendlier. I still don't love that I have a fraction right here. So again, I'm going to multiply everything in this equation by 2 again. And at this point, I just need to isolate the S sub 2, and I'll have my answer. So subtract an S sub 2 from each side, combine the 30 and the 10.5. And the last step is you need to divide by 3, and that gets you the correct answer of 13.5. So the complexity here is really when you have an unknown term in the sequence, you sometimes want to substitute and replace that entire unknown with what you do know. There was a question in the chat. Why do we multiply by 2? The first time we were multiplying by 2, it's to clear this denominator. And then the second time we multiply by 2, it's to clear that denominator. And I realize I wrote it a little bit differently each time, if it helps. Both times I'm doing that step, it's really just multiplying the entire equation by 2. And it's to clear out those denominators. Okay, here is another sequence. This time we're looking for something a little different, so make sure you read carefully. So I'm trying to build up to the 15th term here. And doing that manually one term at a time would take too long to do efficiently on this test. So what you want to look for is some sort of pattern that can help you out and extrapolate to that 15th term. And when I'm looking for a pattern, what I like to do is just list out the first 3 terms and see if I can see a pattern developing there. The initial term, right? The first term is going to be whatever the 0th term is plus 10. And that second term, it's going to be the first term plus 10. And the third term, it's going to be the second term plus 10. And what I notice is whatever term I'm on, that's the number of 10s I'm adding to that 0th term. So from there, I can extrapolate and say like, okay, by the time I'm on the 10th term, I'm going to be adding 10 of those 10s. By the time I'm on the 15th term, I'll be adding 15 of those 10s. And the difference here means you'll have 150 minus 100, which is choice D. And one thing I'd recommend being careful of when it comes to sequences is I encourage you not to oversimplify. If you reduce the math too much, it's going to be harder to identify what the pattern is. And what I mean by oversimplifying, that would be something like for a sub 2, combining the 10s into 20s. And for a sub 3, combining the 10s into 30s. Because these are multiples of 10, you might still be able to see the pattern because 10's not a difficult number, but I think it's much easier to see when you sort of leave that amount you're incrementing by, leave that intact. Don't just combine that into a bigger number. Generally on the GRE, things are simpler when you're leaving the numbers smaller, and things get more complex if you build them up into bigger numbers. So you want to be able to keep working with smaller, simpler numbers when you can. Okay, here's a similar question. See if you can find the pattern here and answer the question. Again here, I think the simplest thing you can do is just examine the first few terms. So your first term is 10 times the 0th term, and the second, you're multiplying by another 10. So that's going to be 10 squared. And then you multiply by another 10 for the third. And again, you've got this pattern where whatever term of the sequence you're on, that's the same as the exponent attached to that 10 we're multiplying by. So the 8th and 10th term, you're going to have 10 to the 8th and 10 to the 10th. And together, 10 to the 10th is 100 times greater than 10 to the 8th, right? There's a difference, or not a difference, but it's 10 squared times greater, and that's 100. Okay, here's another one involving a pattern. So using my definition, I'm just going to list out the first few terms here. And if I rewrite S sub 3 a little bit different, that's where I get a pattern I can easily extrapolate. That the sequence I'm on, that term number is the number of k's I'm adding to j. So here's where I can use the information about S sub 10. That's equal to 32, and I know I must be adding 10 k's to j because I'm on the 10th term. So to solve for j, what I'm going to do is take this information that j plus 3k is equal to 11, and I'm just going to line that up directly under that blue information I have about S sub 10. Because now if I subtract these two equations, I'll have j minus j, the j terms will just go away, leaving me with 7k is equal to 32 minus 11, which is 21, which means k itself is 3. So now I've got my value for k, and I'm just going to take one of my equations I started with, like j plus 3k equals 11, pop in 3 for k, and solve for j. And you'll see the answer is 2. And this technique in green over here, if you're unfamiliar, this is something we call stack and add or stack and subtract, also known as elimination. And it's a great technique when you have two variables and two equations. So give that a search if you're looking to get more practice there. Okay, up next, you'll never guess, it's another sequence. Try it out. So here are the first few terms of this sequence listed out, because I know building all the way up to 8 to the 35th, one step at a time, would take too long. So I'm looking for a broader pattern I can extrapolate here. And some of you may be able to see in this current form what the pattern is. To make it a little clearer, I might rewrite the arithmetic like this to see that the pattern is whatever my term number is, I have 11 plus one fewer of that term number times 9. Or written as a sequence, the current term equals 11 times the term number of the previous term times 9. Kind of a mouthful, but what this means is if I want to find a sub 35, I'm going to start at 11 and then add 34 times 9 to that value. And you do the math, and you should get 317. Okay, we got a couple more here. They both are kind of still on this theme of patterns, but the patterns in these last two take on a different form. Here's the first one. So the first few terms here, you can see the pattern is that it's alternating back and forth between -1 and +1. In fact, you might notice that whenever your term is odd, the output is -1. Whenever the term is even, the output is +1. So all the way up to the 20th term, 19 before it's going to be -1, 20 is going to be +1. And if you sum all these -1s, for every -1, there is a +1 canceling it out, which is to say the sum here, it just comes out to 0 in the end. Okay, one last sequence problem. It's kind of a doozy. See if you can figure out the pattern here. And then we'll do a little recap about what we discussed today. Here it is. From your sequence definition, all you're doing is taking the difference of the previous two terms. So the math is not complex. What's difficult here is staying organized. So you have the first two terms given to you, and then you just need to take the difference to figure out the next term. And I'm going to keep doing this until a pattern becomes apparent. And as you move through the terms, everything is a unique value. Until you get to the 7th term, you see another 1, which means the 8th term, you'd have another 3, and this pattern would be repeating at that point. In other words, in this sequence, the output is going to be this pattern: 1, 3, 2, -1, -3, -2, over and over, forever. Which means every 6th term is going to be the final member of that pattern, right? Whether it's the 6th or the 12th or the 18th or the 24th term, those are all going to spit out a -2. And at that point, after every 6th term, the previous values have all canceled themselves out to 0. So I just need to find how many cycles of 6 do I have up to 100. And 96 is the last multiple of 6 that's less than 100. So I know that's going to be a -2. And that sum has kind of zeroed out again at that point. So look at the 4 remaining terms: 97, 98, 99, and 100. It's going to be these 4 values summed together. The 1 and the -1 cancel out. So really, it's the sum of 2 and 3, which is choice A. 5 is the correct answer. So to recap some of the most important things we talked about. One of my favorite sequence tricks is just defining it in words, that if you try and redo the equation over and over, it can be kind of a slog. But if you get crystallized on the sequence in words, that can help make the math a bit faster. And if you're moving backwards in the sequence, what you need to do is do the opposite operation in the reverse order. Another thing to be careful of is don't try and oversimplify the sequences. As you're doing those outputs, it's kind of leaving the operations intact. That'll help you out. For example, we had a sequence earlier that was something like a to the 4th equals 11 plus 3 times 9, right? And it's leaving it as 3 times 9 that makes the pattern easier to see. If you rewrite that as 11 plus 27 and then simplify that into 38, it kind of obscures what's actually going on behind the scenes. It's keeping the pattern or keeping the operations intact that makes the pattern more prone to reveal itself. So don't oversimplify the math. You want to leave some operations going on so you can detect the pattern. And finally, if you're given an impossible task and you're asked to find the value of like the 20th or the 35th term, anything like that, they're not actually trying to see if you can just go through one at a time all the way to that member of the sequence. Instead, you want to try and find the pattern. So list out the first 3 terms, maybe 4 terms, see what makes sense there. And once you identify the pattern, that's how you can extrapolate to a larger term. All right, and that's going to do it for today. Thanks for coming here and checking it out, those of you who stuck around in the live room. And if you watched on YouTube, I hope you enjoyed. If you'd like to check out more prep hours in the future, there should be some links in the description, or you can visit this link on my screen right here. And one thing in addition to the free prep hours is we also teach a 9-session course at Manhattan Prep all about the GRE, and we open session number 1 up to the public. So if you want to check out a free session, it's a 3-hour session. You can't beat free. So, come check it out. So yeah, I hope to either see you at one of these free sessions or at another prep hour in the future. And if you're in the chat, I'll also pop that link in the chat for y'all there. Okay, I'm going to go ahead and stop the recording. See you next time.